NVIDIA says RTX Spark is a consumer PC, but then why does it have 120 GB of unified memory and up to 1 petaflop of AI performance? And more importantly, who exactly is this product for? Hi there, I was checking out NVIDIA's new RTX Spark lineup and honestly I found it quite impressive. The idea of running large AI models locally without relying on the internet inside a compact portable machine is genuinely fascinating. Modern AI systems like ChatGPT are built on neural networks containing billions of parameters, executing trillions of floating point operations through tensor accelerators to generate responses one token at a time. RTX Spark represents an attempt to move a portion of these data center class AI workloads onto consumer hardware. NVIDIA is essentially trying to shrink the computational demands of an advanced AI system into a device which will be compact enough to fit inside your backpack. And if you are a tech enthusiast, you probably understand how ambitious that vision is. But then I watched NVIDIA's GTC Taipei keynote. And that's where I found myself asking a very different question. If this is a consumer product, then why does it look so much like a workstation? Well, before we answer that, let's understand what RTX Spark actually is. Traditionally, a computer has separate components: a CPU for general computing, a GPU for graphics and gaming, system RAM for the CPU, and VRAM for the GPU. RTX Spark simply changes that approach. Instead of treating AI as another feature running on top of a PC, NVIDIA is designing the entire system around AI from the beginning. The platform combines an ARM-based CPU, Blackwell RTX graphics, dedicated AI acceleration hardware, and unified memory architecture. The two features NVIDIA highlighted the most were 120 GB of unified memory and up to 1 petaflop of AI performance. To put that into perspective, if a person could perform one calculation every second without sleeping, it would take over 31 million years to complete what RTX Spark's AI hardware can theoretically process in just 1 second. Of course, these are specialized AI operations performed by tensor cores rather than general purpose calculations. But it gives you an idea of the computational scale we are talking about. So, what exactly is unified memory? It means the CPU, GPU, and the AI processors all share the same memory pool, similar to what we see in modern MacBooks. In a traditional gaming PC, 32 GB of RAM and 16 GB of VRAM are separate resources. But in a unified memory system, the entire system can access one large pool of memory. This can be extremely useful for the AI workloads because large AI models often require enormous amounts of memory. NVIDIA's vision is that future PCs won't simply run applications. Instead, they will run intelligent AI assistants capable of performing tasks, generating contents, and interacting with software on behalf of the user. During the keynote, Jensen Huang demonstrated an AI agent running locally on an RTX Spark system. Using an open sandbox environment powered by the Hermes agent framework, the AI was able to interact with software tools on the laptop and assist in designing a house based on simple prompts provided by the user. So, in simple terms, RTX Spark isn't just another PC, it's NVIDIA's attempt to build an AI-first computer for the next generation of computing. Now, let's come back to the original question. Who exactly is RTX Spark for? NVIDIA presented RTX Spark as a consumer product. We heard terms like 128 GB of unified memory, local AI agents, and AI-first computing. On paper, it sounds revolutionary. But when I look at it from the perspective of an average consumer, I start to see a contradiction. And again, this is just my opinion. I would genuinely love to hear your thoughts in the comments. Most of the consumers like us use their computer for gaming, web browsing, watching content, office work, or occasional creative tasks. They don't need 128 GB of unified memory. They don't need to run massive AI models locally. They don't need workstation level AI compute powers. What they need is simple good performance, good battery life, reasonable pricing, and most importantly, value for money. And this is where my concern begins. The specs NVIDIA is highlighting feel more like a prosumer than a traditional consumer device. Well, in many ways, RTX Spark reminds me of a MacBook Pro. A MacBook Pro is an incredible machine, but most people don't buy one because they need 128 GB of memory or because they simply want to run Cyberpunk in native 4K with ray tracing in overdrive mode. They buy it because they are editors, developers, designers, engineers, and professionals whose work genuinely benefits from that hardware. The average consumer usually don't need that level of computing power. So when NVIDIA says consumer, I can't help but wonder whether they actually mean prosumer. And this brings me to pricing. To understand my concern about RTX Spark, let's look at apples Apple's unified memory pricing. On a modern MacBook Pro, moving from 24GB to 48GB of unified memory can add roughly $400. Moving further to 64GB can add another couple $100 depending on the configuration. So that means memory upgrades alone can cost around $600 before we even talk about storage, displays or processor upgrades. Now, I am not saying NVIDIA will follow Apple's pricing model, but Apple's approach gives us an idea of how expensive integrated memory can become. If RTX Spark follows a similar pattern, high-end configurations could become significantly more expensive than traditional gaming laptops. This is why I think pricing will be one of the biggest tests for RTX Spark, because technology is only consumer friendly if consumers can actually afford it. Now let's talk about gaming. And to be clear, I am not against AI. AI can be incredibly useful for productivity, noise reduction, transcription, object selection, and creative workflows. My concern begins when AI starts becoming a substitute for raw hardware performance. Historically, PC gaming has always been about hardware capability. More cores, more bandwidth, more rendering power. When gamers buy a new graphics card, they expect stronger native performance. They pay hundreds, sometimes thousands of dollars because they want better hardware, not because they want software to compensate for hardware limitations. And yes, technologies like DLSS and frame generation are genuinely impressive. They improve image quality, they increase frame rates, and they improve the overall gaming experience. But they are not the same thing as raw performance. Even during RTX Spark demonstrations, NVIDIA showed Forza and 007 First Light running smoothly on remarkably thin laptops, and that is really impressive. But naturally, one question comes to mind. Exactly how much of that performance is coming from the hardware itself? And how much is coming from AI-assisted technologies? Because there is a difference between rendering a frame and generating a frame. We saw this debate during the RTX 50 series launch as well. NVIDIA showcased scenarios where the RTX 5070 appeared to deliver performance comparable to or even exceeding the RTX 4090. However, independent testing data showed that much of that advantage came from the technologies like DLSS and multi-frame generation, rather than superior native rendering performance. Still, even now, in many traditional hardware-based workloads, the RTX 4090 outperforms RTX 5070 with significant lead. AI-assisted performance can absolutely improve the gaming experience, but it shouldn't blur the distinction between generated performance and hardware capability. I learned this lesson a year ago while editing videos in Premiere Pro. I didn't have a graphics card back then, so I relied entirely on software encoding. The difference between software encoding and hardware acceleration was massive. I eventually bought a GPU primarily because of that feature, even though it nearly destroyed my budget at that time, but it was worth it because I was paying for the actual hardware capability. That experience is one reason why I still value raw hardware performance today. And maybe this analogy is unfair, but sometimes it feels like putting a V8 engine inside a hypercar and then using software to convince me that I am getting the performance of something much bigger. Well, the experience may improve, but I still want to know what the hardware is truly capable of. Because PC gaming has always been different from consoles. It offered control, customization, upgradability, and access to the full power of the hardware. That identity should not be lost. Which brings to my final concern. Unified memory can be excellent for AI workloads and professional applications, but it also moves the industry towards a future where memory is integrated, non-upgradable, and potentially very expensive. One of the greatest strengths of the PC platform has always been flexibility. Need more RAM? Upgrade it. Need better GPU? Replace it. Need more storage? Simply put another drive. If future systems become increasingly closed and dependent on fixed configurations, consumers may lose one of the biggest advantages that made PCs attractive in the first place. And if integrated memory fails outside warranty, repair could become significantly more expensive than simply replacing a RAM stick in a traditional PC. To be clear, I am not saying RTX Spark is a bad product. I think it could be an incredible machine for AI developers, content creators, and professionals. What I am questioning is whether this is truly a consumer-first product or whether it is a professional AI workstation being marketed as one. The technology is impressive, the vision is ambitious, but beyond RTX Spark itself, perhaps the bigger question is this: what does a product like this mean for the future of the modern PC market? Because if AI first, tightly integrated systems become the norm, the very philosophy that has defined PC gaming and PC building for decades could begin to change. For years, the PC has stood for freedom, the freedom to choose your components, upgrade your hardware, and build a machine around your own priorities. If that future shifts toward fixed configurations, unified memory, and increasingly closed ecosystems, will traditional gaming rigs become a niche reserved for enthusiasts? Or will consumers continue to demand the flexibility, upgradability, and raw performance that made the PC platform what it is today? I don't know the answer, but I do believe that the answer to this question won't just shape the future of RTX Spark, it may shape the future of the PC itself. What do you think? Is RTX Spark the next evolution of personal computing? Or are we slowly moving away from the very philosophy that made the PC special in the first place? Let me know in the comments below.